Good day, everyone. For today, we'll be discussing mixture problem. This is an interesting application of differential equations to mixing of some solutions. In mixture problems, what we usually have is the model that the rate at which a substance comes in the tank is equal to C in Q in minus C out Q out. So the rate at which a substance comes in the tank is your dx over dt. So this is flow rate of a substance. An example of this would be a salt solution which easily dissolves into water. So we can have the varying concentration of salt of a fluid in a tank. So dx over dt is equal to C in Q in minus C out Q out. So C in is your inflow concentration. Q in is your inflow rate. So this is the rate at which the fluid is going in the tank. Q out is the outflow rate of fluid. So this is the rate at which the fluid in the tank exits the tank. Now for C out, so unlike this first three, which are constant, so it should be Q in T minus Q out T. So V out, V or the volume is equal to initial volume V sub 0 plus Q in minus Q out times T. So basically, the equation would now be dx over dt equal to C in Q in plus C out is x over V out, V sub 0 plus Q in minus Q out times T times Q out. Now let's solve some problems involving mixture. A tank contains 200 liters of fluid in which 30 grams of salt is dissolved. So for this, we have the initial volume, which is 200 liters, in which 30 grams of salt is dissolved, meaning the initial amount of salt in the tank is 30 grams. Brine containing 1 gram of salt per liter is then pumped into the tank at a rate of 4 liters per minute. So we have here a data for inflow. So we have 1 gram of salt per liter. So that is a concentration going in 1 gram per liter. It is then pumped in the tank, Q in, at a rate of 4 liters per minute. The well-stirred mixture is pumped out at the same rate. So we're going to have the outflow. So the outflow is Q out equal to 4 liters per minute. Find the number of grams of salt, A of t, in the tank at time t. So we can say that the amount of salt in the tank is X, which is what I have used here. X sub 0 is 30 grams. So it is changing as a function of time. Let's start with finding the volume of salt of the fluid in the tank. So that is 200 V sub 0 plus Q in minus Q out times T. So this is your V sub 0. So the volume of fluid in the tank is now 200 plus 4 minus 4 T. 4 minus 4 is 0. So the volume is 200 liters. Now we need to find the rate at which it is changing. So instead of dx over dt, so since it is stated that we should be using A, so we will be using dA over dt equal to C in, Q in, minus C out, Q out, equal to C in. So your C in is 1 gram per liter, Q in is 4 liters per minute, and Q out is 4 liters per minute. So we have 1 times 4 minus C out. Your C out is X over V times Q out, which is 4. So we have dA over dt equal to 4 minus 4. And then, by the way, your X is the amount of salt in the tank. So we can have it as A over 200. So this would now be 4 minus A over 50. So we can have this one written as dA over dt plus 1 over 50A equal to 4, where A of 0 is, so this is also your A of 0. A of 0 is 30. We can solve this using Laplace transform. So we can have S, A of S minus A of 0 plus 1 over 50 A of S equal to 4 over S. Since A of 0 is 30, so we can have A of S times S plus 1 over 50 is equal to 4 over S plus 30. So we have A of S is equal to 4 plus 30S all over S times S plus 1 over 50. With this, we can take its partial fraction equivalent, A of S equal to some function with the denominator S and another function with the denominator S over 1 some function over s plus 1 over 50. So when s is 0, we would be having 200. So that would be 4 over 1 over 50. So that is 200. And when s is equal to negative 1 over 50, so we have 4 minus 30 over 50 all over negative 1 over 50. So we can have b equal to, maybe we can multiply both numerator and denominator by 50 or by negative 50. So that would be negative 170. So from this, you can observe that we would be having your amount as a function of time to be 200 minus 170 e to the negative t over 50. The unit is in grams. Let's check whether we have answered the problem completely. So find the number of grams of salt A of t at any time t. So we have here A of t equal to 200 minus 170 e to the negative t over 50. At time equal to 0, so it would be 200 minus 170, which is 30 grams, the initial condition. And also, as t approach infinity, so t to the negative infinity is approaching 0, so 200 grams. So the fluid going in has a concentration of 1 gram per liter, and it is coming in at a rate of 4 liters per minute. So since it is 1 gram per liter and we have 200 liters, so we are expecting that after in sufficient amount of time, it would be equal to 200 grams as well. Okay, let's have another problem. A large tank is partially filled with 400 liters of fluid, in which 5 kilograms of salt is dissolved. Brine containing 0.25 kilograms of salt per liter is pumped into the tank at a rate of 20 liters per minute. The well-mixed solution is then pumped out at a slower rate of 15 liters per minute. Find the number of kilograms of salt in the tank after 30 minutes. So we are given with initial condition. The initial volume is 400 liters. And the initial amount x sub 0 is 5 kilograms of salt being dissolved in the tank. So for inflow, we have the concentration C in equal to 0.25 kilogram per liter. It is being pumped in at a rate of 20 liters per minute. For outflow, so C out is equal to X over V, while Q out, it is equal to 15 liters per minute, a slower rate. So the volume at any time is equal to the initial volume 400 plus 20 minus 15 or 400 plus 5t. With this, we can have your dx over dt equal to x in, uh, salt coming in, so that would be C in Q in minus C out Q out equal to 0.25 times 20 minus x over 400 plus 5t times 15, x over v. So x is x and v is 400 plus 5t. So we can simplify dx over dt equal to 0.25 times 20. So maybe we can use our calculator for this. So we have 5 minus. So both 15 and 400 plus 5t is divisible by 5. So we have minus 3x. So we divide the numerator 15 by 5. So that would be 3. And then 5t is t. And then 400 divided by 5 is 80. So we have dx over dt is equal to 5 minus 3x over t plus 80. So we have dx over dt plus 3 over t plus 80 x equal to 5. So this is a linear differential equation, and we can solve this. So we can have x is equal to the integral of e to the integral of p of t dt q of t dt all over e to the integral of p of t dt. So that would be the integral of e to the integral of 3 integral of dt over t plus 80. Q of t is 5 dt all over e to the 3 integral of dt over t plus 80. So we can have x to be equal to the integral of e to the 3 ln of t plus 80 times 5 dt all over e to the 3 ln of t plus 80. So this 3 can be an exponent of ln of t plus 80. So that would be the integral of 5 e to the ln of t plus 80 cube dt all over. It would just be the same. It would be t plus 80 raised to 3. So the integral would give us 5 times t plus 80 raised to 4 over 4 plus c all over t plus 80 cubed. So our x would be equal to 5 over 4 times t plus 80 plus c times t plus 80 raised to negative 3. At t equal to 0, x is equal to 5. So we have 5 is equal to 5 over 4 times 0 plus 80 plus c 0 plus 80 raised to negative 3. So we have 5 minus 100 is equal to C over 80 cubed. So C is 80 cubed times 95 negative. So we have negative 48,640,000. So we have X now being equal to 5 over 4 times T plus 80 minus 48,640,000 all over T plus 80 cubed. To solve for the unknown, the number of salt in the tank after 30 minutes, so we have X is equal to 5 over 4 times 30 plus 80 minus 48,640,000 over 110 cubed. So we have X is 137.5 minus 36.54. So X is 100.95 kilograms. So it would be quite complicated if the inflow is different from the outflow. Now, let's have the last problem. A tank 400 grams of brine in which 100 pounds of salt is dissolved. Fresh water runs into the tank at a rate of 2 gallons per minute. So let's have a correction for this. It should be 400 gallons. So a tank contains 400 gallons of brine in which 100 pounds of salt is dissolved. Fresh water runs into the tank at a rate of 2 gallons per minute, and the mixture, kept practically uniform by stirring, runs out at the same rate. How much of salt will there be in the tank at the end of 1 hour? So we have the initial volume, 400 gallons. The initial amount of salt, 100 pounds. So for inflow and then outflow, fresh water runs into the tank at a rate of 2 gallons per minute. So C in is 0 because there's no salt in fresh water. At a rate Q in 2 gallons per minute. It is kept practically uniform by stirring and runs out at the same rate. So Q out is also 2 gallons per minute. How much salt will there be in the tank at the end of 1 hour? So for C out, we would be having X over V, and the volume is equal to VO times Q in minus Q out times T. So the volume is 400 gallons plus 2 minus 2T. So the volume is constant at 400. dx over dt is equal to 0 times 2 minus x over v. So we have x over 400 times q out of 2. So we now have dx over dt equal to negative x over 200. Simplify this by multiplying dt. So we have dx over x equal to negative 1 over 200 dt. And we can integrate this. We want from time 0. So we can have our timeline for t and x. So at t time equal to 0, the amount of salt in the tank is 100 pounds. After 1 hour, so after 60 minutes, because the given is in minutes, gallons per minute. So after 60 minutes, we're looking for x of 60. So initially, when time is 0, x is 100. And at time 60, we are looking for x of 60. So we have ln x from 100 to x equal to negative 1 over 200t from 0 to 60. So we have ln x minus ln 100 is equal to negative 1 over 200 times 60 minus negative 1 over 200 times 0. So we have ln x equal to ln 100 minus 60 over 200. So we can have x to be equal to e raised to ln of 100 minus 3 over 10. So that would be e to the ln of 100 times e to the negative 3 over 10. So x is 100 times e to the negative 0.3. So x is approximately equal to around 74.08 pounds. So here, initially, the amount of salt in the tank is 100. And since we are pouring in fresh water, dissolving the concentration of salt in the tank and then releasing it by discharge, so it would be eventually be, as time approach infinity, it would be 0. But after 1 hour, it would just be 74.08 pounds